Algebra 2, Lesson 106, more on systems of three equations. So there's nothing new we're learning in this lesson. We're just using a new method to apply old techniques. The techniques being substitution and elimination for three systems of unknowns. So let's get straight to it. Now, the difference on these equations as opposed to the ones you previously solved, you may notice each equation does not have x, y, and z. They've only got two of the three terms. For example, this first equation is missing the x term, this middle one is missing y, and the last one is missing z. So that kind of makes it a little difficult to figure out how to substitute and eliminate between them. Well, the solution is to use elimination, and we're going to use elimination on all three equations, and we're going to pretend like all of them have x, y, and z. So, for example, this first equation is missing x. So, actually I'll label this. I'm going to make a little graph for you guys. This will be the x column, this will be the y column, this will be the z column, equals, and then the number column. All right. So this first equation, 3y minus 2z, there's nothing in the x. There's nothing in the x column, so we'll go ahead and leave that blank. Let's see, we'll switch over to black. So then I'll take 3y and I'll put that under the y column. 3y minus 2z equals the number negative 12. So that's the first equation. You may not see what I'm doing yet, but you'll see it on the second one. Now the second one, I'm missing y. So I have 2x. So I'll put 2x in the x column. I have no y, so I leave the y column blank, and then I put negative 3z in the z column. And then lastly, I put equals negative 5. Now the last one, so you might see what I'm doing here is I'm just treating each equation like it has the number, but leaving a blank where it's missing. The last equation is x minus 2y equals 6. So x minus 2y, no z term, so I'll leave that blank, equals positive 6. So now I've got all three equations written in a grid where I've got, the spaces for the ones that are missing. Now I'm going to go ahead and go to using elimination. So to use elimination, I want to get rid of either the x, the y, or the z by making them have the same coefficient with the opposite signs. I already see that the y's have opposite signs, so I'm going to go ahead and eliminate y. So to eliminate y, I have to make them both read 6. So I'll multiply the top equation by 2. Let's see here. And then I'll multiply the bottom equation by 3. Now when I do that, what I end up getting is 2 times 3y becomes 6y, 2 times negative 2z becomes negative 4z, and then this becomes negative 24. Why is my focus off? What's going on here? There we go. Then here on the bottom, this becomes 3x, this becomes negative 6y, and this becomes positive 18. So now when I use the elimination, I'm going to add all three equations together, not just the two that I changed. I'm going to add all three equations together. You'll see why. So when I'm adding, I'm going to take 2x plus 3x, that gives me 5x. The 6y minus 6y cancels, so that is gone. Negative 4z and minus 3z gives me negative 7z. And then let's see here, negative 24 plus negative 5 is negative 29. Negative 29 plus 18 is negative 11. All right, so once I've done that, I now have one equation with x and z. And if you remember, I had another equation with x and z here. So I'm going to take this equation, I'm going to combine it with the other x and z equation, and through one more step of elimination, I will then have solved for one of my missing numbers. So I'll go ahead and eliminate x because 5 and 2 is pretty simple multiplication. Let's see here, this one's going to get multiplied by 2, this one gets multiplied by 5. And I'll go ahead and rewrite these below because I didn't give myself a whole lot of space. So the green equation, when I multiply by 2, becomes 10x minus 14z. Oh, yeah, okay. Equals negative 22. Now the bottom equation I forgot, I'm actually supposed to multiply by negative 5. So that way it's got the opposite sign. So then negative 5 times 2x gives me, oops, we gotta switch over to blue for the blue equation. Negative 10x. Negative 5 times negative 3 gives me positive 15z. That's cool. Negative 5 times negative 5 gives me positive 25. So now I eliminate and I'll find out what z equals. So the x's cancel. Negative 14 plus 15 is just 1z, and then negative 22 plus 25 is 3. So z is equal to 3. Once I know that z is equal to 3, I can take this value and I can plug it into these equations to start solving. So I'll go ahead and use the top equation. So the top equation reads 3y minus 2z equals negative 12. So 3y minus 2 times z, which has a value of 3, equals negative 12. 2 times 3 simplifies. Oops, let's go with orange. 2 times 3 simplifies, becomes negative 6 equals negative 12, 3y. There I'm going to add 6 to each side. Cancel, and then I have 3y is equal to negative 6. Last step is divide by 3. Negative 6 divided by 3. Oops, I just realized that was off paper. So last step, I divide by 3. Negative 6 divided by 3 is equal to negative 2. So now that I know that z is 3 and y is negative 2, I can then pick any one of these equations with x and solve for the last unknown. So I'll go ahead and do x minus 2y equals 6. So if y equals negative 2, and then I know that x minus 2 times y negative 2 equals 6, well, then I simplify. X plus 4 equals 6. Yeah, negative 2 times negative 2, that's 4. And I subtract 4 from each side, and then I get x is equal to 2. So x is equal to 2, y is equal to negative 2, z is equal to 3, and I write my final answer in a coordinate triple. So it'll be 2 for x, negative 2 for y, and 3 for z. And that is my final answer right there. If you guys have any questions, let me know on Moodle. If not, I will see you in class.